Okay. Up to which point we have yesterday? Can I summarize? Can anybody able to summarize? Up to which portion we have covered? Anyone? Can anybody able to summarize? Are you able to listen to me? Are you able to listen to me? No. Yes or no? If all of you are that much silent in the lecture, then how can I come to know about whether you're getting on? Are you able to see? Hello? Hello? Are you able to listen to me? Do you hear me? Now, are you able to listen to me? Do you hear me? Now it is clear? Now it is clear? Yeah, okay. Yesterday, up to which portion we have covered, we have seen the last two implementation, physical layer implementation, which comes under the fast Ethernet, that is 100 base FX and 100 base T4. And we have also seen what are the encoding methods they have used in the case of your FX, in the case of your T4. Okay? Now, yesterday we have covered the introductory part of the Gigabit Ethernet, where we have discussed about the IEEE, IEEE standardization given by the Gigabit Ethernet is 802.3Z, and the goals already which we have seen in the fast and standard Ethernet, we have already seen that goal is somewhat same similar in the case of your Gigabit Ethernet also, but slight changes there. Changes is there. This Gigabit Ethernet is upgraded the data rate to 1 gigabit per second, and it is compatible with the standard or fast Ethernet, and it is also use the same 48-bit address, and the frame format is same. Just if this one difference is that, and for minimum the minimum data we can transfer, that is the 46 bytes, but in the case of a gigabit internet, we can extend or extension for this minimum. They have extended the somewhat minimum of it. Okay? They have increased the data by more than, that is for 512 bytes. They have increased somewhat the minimum. During minimum 46 bytes to normal traditional methods, they have increased to 512. Now, also it follows the that features which is applied in the fast Ethernet, that is auto negotiation. Now, Sublaayer. So first, Sublaayer is the Sublaayer. तो यहाँ पे जो हम लोग अभी क्या डिस्कस करेंगे, what is the how it is accessible. So you are going to access the channel, and there are two ways through which we can use. There are two approaches normally. They under the Gigabit Ethernet, that is full duplex and half duplex. Okay? And under your half duplex, it will see the diagram. Under your half duplex, the sub approaches, that is traditional, carrier extension, and frame bursting. So we'll discuss about the full duplex. Now in the full duplex, this is not happening because for sending and receiving, they can normally use two different channels for transmitting and receiving. Fine. And because of that, collision is not happening. And because of that, it's not required to use any type of method for agency. And this is for every station channels, there are two channels for transmitting and receiving for receiving the, and because of that the collision problem is not happened in the case of your full duplex. This type of diagram is known as full duplex switched Ethernet. Next is the half duplex. In the half duplex, normally a single cable we are normally used for transmitting and receiving, and because of that, the CSMA it may happen, collision may happen, and because of that, there are three approaches they have normally used under this Gigabit Ethernet. So ट्रेडिशनल, फर्स्ट वन इज द ट्रेडिशनल. एज ए ट्रेडिशनल हम लोगों ने जो ऑलरेडी देखा है कि ट्रेडिशनल आपका जो मिनिमम जो आपने एलोकेट किया है फॉर डेटा इज दी 46 बाइट्स, बट हम वही यूज करेंगे. बट स्लॉट टाइम जो है, स्लॉट टाइम बाय 100 दैट ऑफ ट्रेडिशनल इथरनेट. 1/100 मीन्स व्हाट? It will detect 100 times earlier the collision as compared to the your standard Ethernet or fast Ethernet. That means what? Slot time. It will detect the 100 times earlier the whatever collision happened. It will detect 100 times earlier as compared to your traditional Ethernet. Clear? That is the first traditional half duplex. Second one is the carrier extension. What do you mean by carrier extension? Carrier extension, here what will happen here, as we will know about the minimum frame length, that is 512, is the traditional one. But in the case of your Gigabit Ethernet, they have increased the frame length to 4096 bits. That means what we can say? We can say that it is of 512 bytes. 512 bytes. So they have increased the minimum frame length to 4096 bits. That means what? It will transmit the frame, first frame, one frame, and if it is minimum, if it is not fulfill the minimum frame length of 4096 bits, we have to go for the padding. It will fulfill the minimum frame length of 4096 bits. Yeah, so this is the carrier extension half duplex. And last one is the frame bursting. What about frame bursting? What will happen? Instead of transmit a single frame at a time, after a single transmit cut, and what will happen? You will wait for the acknowledgement to come. Instead of transmitting frame, you will go for it will transmit multiple frames at a time. That's why in this case, concentrated means of the thing together because of multiple frames transmitted instead of small frames. And whatever the frames we transmit here, we have to pad for what purpose we are padding, so that it will fulfill minimum requirement of, that is of 09 bits. That is the three you can say is the three sub approaches which come with your half duplex. So we may just summarize in the Gigabit Ethernet whatever I have used. That is, one is full duplex, where it is not, where each and every station use its own channel for transmitting and receiving the receiving purpose, and because of that they have individual channels, and because of that the collision problem is removed in the case of your full duplex Ethernet approach, Gigabit Ethernet approach. In the case of your half duplex, they have go on the half duplex because normally the collision happened in the case of your half. So they have used some approaches so that this collision problem should recover or will not recover, at least it will reduce. The first they have used is a traditional one. In traditionally, how you are transmitting the data, we are normally transmitting the data, then the data, whatever the data, it should recover, fulfill the minimum of 512 bits, but that is the traditional method कि आपका जो minimum length of frame length, that is 512 bits. Whenever you are transmitting the whatever the frames you are transmitting, it should fulfill that one. But they have gigabit Ethernet. The slot time, whatever is given shown to you, the slot time what if collision happens, it will detect 100 your traditional Ethernet, because your traditional Ethernet is means the 1 gigabit and 100 times and sorry Ethernet is 1 megabit, but your gigabit Ethernet is of 1000 gigabit Ethernet. Because of that, it um, detect the collision earlier. Fine. So next is the so if so in the if your carrier extension, they have increased your minimum 312 to 4096 bits. Fine. Going to convert it to bytes, that is 5 bytes. Okay. Now, and last one is the frame bursting. Instead of transmitting one frame at a time and then wait for the acknowledgement, and because of that, it will anyhow extend the time period. Because of that, to recover this, they are normally transmitting the single frame, multiple frames at a time. That means what? In a window, is in a window wise, not in a single frame. It's not. They are not normally used the stop and wait protocol. They are normally use the window protocols which are there, go back and or selective repeat. For time being, you just draw this diagram. For time being, just draw this diagram. Just draw this diagram. Drawn, everyone? Okay, next. Draw this diagram. Over? Over? Shall I move to the next? Yeah, okay. Draw this one. Drawn, everyone? Hello? Okay. This is for the frame bursting. Draw it. Now next is the physical layer. Or covered now the max layer. Now next is the physical layer. In the case of the physical layer, the topology network used is SSG or point to point. Use this topology here and whatever in your fast internet, there are stations are there. We point connection. There are more than two stations are there. Go for start type arrangement where every stations are connected with a switch, right? So the first the implementations of gigabit Ethernet. It is the implementation of gigabit Ethernet. Before that, you just draw this diagram. It is just draw this diagram, which you can write down the topic physics under this, write it topology, and then draw this diagram. My voice is breaking. Okay, I'll explain again. This is the physical layer of gigabit Ethernet, and here the what fast Ethernet also, that if we'll go using the stations for the point-to-point, and if there more than stations are there, we go for the start type. That two, there are two more than two stations are if you are using, then we go for the network arrangement. It is of star topology, and where the stations are connected with a switch. Okay, and if there are two different networks are there, the two different switches are connected together in this manner. Fine. So this arrangement, you just draw this diagram. It is. Am I audible now? Am I audible now? Am I audible now? Still it is breaking? Still it is breaking? Hello? No, okay. Oh yeah. Audible.
Audible,
Okay.
ma'am.
You just draw this diagram. The same thing which I have covered in the fast Ethernet, the same thing I have drawn here. Just difference is that if there are two different networks are there, and if two different networks are connected with two different switches, they are combined together and make a common one. Fine. So this is no, happened in the case of your gigabit Ethernet because it's the data rate is also higher. Over. Okay. This is the implementations. That is the physical implementations of gigabit Ethernet, and it is characterized in two ways. How it is characterized? Characterized as either the 2-wire or 4-wire implementation. If you see the level diagram of gigabit implementation, the first three implementations, that is 1000 base SS, 1000 base LX, and 1000 base CX. This is two wire. They are first two they have used the fiber optic cable, and the third one they have used this shielded twisted pair cable. Fine, and the last one is the 1000 base T. They have used the unshielded type of twisted pair cable, but they have used the four bidirectional cables here. Fine. Draw this diagram. Okay. Drawn everyone. Drawn everyone. Okay. The first three, that is your SX, LX, and CS, 1000 base SX, LX, and CS, will the arrangement, the implementations diagram is same for these three. You just that is, and that's why I have written here 1000 base X. Fine. First, you draw this diagram. Okay. Over. Yeah. You're in this diagram. Am I audible? Am I audible? Yeah. Okay. If you see the diagram here, तो मैंने क्या बताया था आपको? This types of implementation they have used two wires, two cables. That means what? One for transmission and one for receiving purpose. ठीक है? So here the block encoding mechanism they have used, it is the 8-bit, 10-bit block encoder. Whatever we have seen in the 4B, 5B, the same method they have used here. So I'm not going to explain here. And out of instead of 4 bit they have used the 8-bit, and per bit requires the 125 megabit per second. Okay, so after using the block encoding, 8-bit encoding scheme, they have data rate is increased to 5 gigabits per second. And after that, for encoding used the line encoding, means whatever the data bit, to convert that data bit to the signals, they have used the line mechanism. It is the not return to zero. See, not return to zero already I have explained you, but whatever I have explained you, it is the not return to zero dash I, that is the inversion. But here I have written here an that line. So NRZ is to one दिया तो zero level. सेम जो हम लोग जो मेथड ट्रेडिशनल यूज करते हैं फॉर को जो हम के सर्च करते हैं हाउ it is not to that I zero to entry the level and one what you go for the chain. No. Make a one it will also be positive negative 0 after 3 बिट में से प्लस पहला अगर 10 हम लोगों ने कहा जस्ट टेक एग्जांपल लिया और सेट का हाँ दिस इज दिस इज हम लोगों ने क्या देखा यहाँ पे अगर बिट 0 but in the case of your NRZ only it is the I मैंने use किया that is the inversion but in the case of your NRZ only देखो दो क्या तो lower level I1 हुआ तो positive level जो normally हम करते हैं तो it will implemented by the it is used by that X implementation for transmitting or for converting your bit into the signals. Fine, and that signal is transmitted through this fiber optic cable and is given to your decoder side. So this is simple arrangement of your one-way bits. Yeah. What use it is linear and the 1000 T. You know, 1000 T. Here, for line for converting your bit into the line encoding, they have used the 4D PAM5. 4D means what? There four bits are four channels are there. Four channels are there, and four channels bidirectional. And for this, they have used the 5 layers. That is plus minus 1 0. Sorry, minus 2 minus 1 0 plus 1 plus 2. So they have used 5 channels for transmitting data. ठीक है? They have used it 125 megabits. Then this is for transmitting the. Hello. Yes. Yes.
आपका वॉइस ब्रेक हो रहा है।
कहाँ तक मैंने आपको कहाँ तक सुनाई दी? हेलो हेलो कहाँ तक सुनाई दिया आपको?
उसके पीछे की स्लाइड कुछ तक नहीं, कुछ सुनाई नहीं
दिया क्या? ओके, आई विल एक्सप्लेन अगेन. ओके, या फाइन.
इसके पहले स्लाइड. हाँ.
नाउ इट इज ऑडिबल. नाउ इट इज ऑडिबल.
यस मैम.
रुकेश ज्वाइन किया आपने? अटेंडेंस ऋषिकेश अनम्यूट योरसेल्फ. आई नो कितने लोग कितने बजे ज्वाइन किए. मैंने पहले ही बोला है नॉर्मली वहाँ पे दिखता है किसने कितने कौन से कितने मिनट के बाद ज्वाइन किया है.
मैम आपका वॉइस अभी भी ब्रेक हो रहा है.
Now it is audible.
Yes,
now,
ma'am.
Yeah, now it is audible. Yeah. So what I am discussing is अगर आप बाहर जाते हो या अंदर आते हो मुझे पता चलता है. एक्सेल शीट पे सब टाइमिंग दिखाता है कौन कितने बार बाहर गया है, कितने मिनट के बाद ज्वाइन किया है. बेस्ड ऑन दिस मैं अटेंडेंस मार्क करती हूँ. आपको समझा क्या ऋषिकेश? Whether he is here? Okay. So what I have explained here, हम लोगों ने जो 5B 4B 5B ब्लॉक एनकोडिंग मैकेनिज्म देखा था, the same thing here, the 8B 10B हम लोग यूज कर रहे थे. मेथड इज सेम बट द डिफरेंस इज दैट कि यहाँ पे 8 बिट को 10 बिट में कन्वर्ट किया जाता है. फाइन. एंड फॉर 8 बिट दे हैव यूज्ड द डेटा रेट ऑफ 125 मेगाबिट पर सेकंड. फाइन. नाउ in the case of your for 8 bit means what per bit requires 125 megabit per second. ठीक है. Now for transmitting for your you can say for converting this bit क्योंकि क्या ब्लॉक के अंदर बिट्स रहते हैं. This bit we have to convert into the signals, data signals, and for conversion or for transmitting the data signals to the other side, what we will we'll go for the one more encoding mechanism जिसको हम बोलते हैं लाइन एनकोडिंग मैकेनिज्म. ठीक है, दिस लाइन मैकेनिज्म जो आपने यूज किया यहाँ पे यूज किया है दैट इज एनआरजेड. तो आप लोगों ने जो पहला वाला जो एनआरजेड आपने देखा था, पहले वाले एनआरजेड पे क्या था, पहले वाले एनआरजेड पे क्या थी, पहले वाले एनआरजेड पे क्या था, अगर बिट 1 है तो नो फॉर द चेंज, बिट 0 है तो नो चेंज. बट इन द केस ऑफ योर ऑन, बिकॉज यहाँ पे हम लोगों ने क्या देखा था, एनआरजेड आई, एनआरजेड आई, दिस इज द एनआरजेड आई. अभी हम किसके बारे में बात कर रहे हैं, ओनली एनआरजेड, नॉट रिटर्न टू जीरो. तो नॉट रिटर्न टू जीरो इम्प्लीमेंटेशन में क्या रहता है, अगर जीरो है तो जीरो की तरफ डाउन, वन हुआ तो अप. ठीक है, तो हम लोग जो नॉर्मल सिग्नल, आप डेटा सिग्नल बिट्स को जो डेटा सिग्नल पे कन्वर्ट करते हैं, जीरो हुआ तो डाउन, वन हुआ तो अप, तो हम यहाँ पे नॉर्मल नॉर्मल ये मैपिंग करेंगे. ठीक है, नॉर्मल मैप करते हैं हम यहाँ पे. ठीक है, तो इन द केस ऑफ एनआरजेड लाइन एनकोडर, एंड थ्रू दिस cable we are transmitted that signal into the decoder side. Clear? Anyone? Any doubt? Any doubt? So here I'm not going to explain you the encoding mechanism. Already I've explained you the 4B, 5B, so I'm not going to explain you. Any? Are you able to listen to me? Hello? Yeah. Okay. So next is the 1000 base T. In the case of your 1000 bit T, यहाँ पे हम लोगों ने जो encoding mechanism use किया, it is the 4D PAM5. 4D means what? We are normally use here 4-dimensional cables and wires, and it is a bidirectional cables. And the levels they have used, it is the 5 levels, voltage levels, working under the 5 voltage levels. And कौन सा है, -2, -1, 0, +1, +2. These are the 5 PAM, pulse amplitude modulation voltage signals they have used for encoding purpose. ठीक है, जो उन्होंने क्या किया है, 4D जो आपका जो भी बिट्स वगैरह है, 8 बिट को उन्होंने इस 5 वोल्टेज चैनल लेवल्स पे कन्वर्ट किया है. क्लियर? नाउ तो यहाँ पे भी अगर आप देख रहे हो तो 8 बिट पर बिट रिक्वायर्स 125 मेगाबिट पर सेकंड डेटा रेट पे वो ट्रांसमिट होता है. And for this they have used the 4 cables, that is for that they, and these 4 cables are bidirectional cables. So this is, and the cable is the twisted pair cable, not the fiber optic cables here. Clear? So this is the generalized offer, because in the in your syllabus this description is not required for the 4D PAM5 encoder. Fine. Just come. That's why I just explain you why it is 5, because it works under your 5 voltage levels. -2 plus -1, 0, +1, +2, and for 4D is the 4 bidirectional cables we have used here. Fine, for transmitting the channels. So if you see here, this is the characteristic. This is the summary of your Gigabit Ethernet, where if you see here for the 10 base SX, 10 base LX, and 10 base CX, then use the fiber optic cables by the SX and LX, and CS is used the twisted pair cable. Fine. A number of wires for the first 3 it is 2 and the last is the 4. Maximum length for the 1000 base SS is 550 meter. For 1000 base LX it is the 5000 meter. For 1000 base CS it is the 25 meter, and for 1000 base T it is the 100 meter. Fine. For block encoding, first 3 they have used the block encoding mechanism is 8B, 10B, but for the 1000 base T they have not used the block encoding. The line encoding was this the purpose of, they fulfill the purpose of this block encoding also. So line encoding में आप क्या देख रहे हो, 1000 base SS, 1000 base LX, and 1000 base CS, they have used the encoding mechanism as the NRX. ठीक है, and RZ, that is the non-return to zero, and for 1000 base T that is the 4D PAM5 line encoding mechanism. So this is, you just draw this, so that you draw this diagram. You draw this diagram. Over. Completed, everyone? Drawn? Okay, आलिया, ये ड्रॉन आपने ये ड्रॉन किया, ये ड्रॉ किया आपने? ड्रॉ drawn, okay. Now write it down. Write down the difference. Over. Okay, till then, okay, this is all about your Gigabit Ethernet. Just summarize once again. In the Gigabit Ethernet, what we have seen? We have seen the goals of the Gigabit Ethernet, and after that we have seen the max layers, that is the max sublayer. And under your max sublayer, we have seen the two approaches, that is the full duplex and the half duplex. Under your half duplex, we have seen the some approaches of half duplex. Half duplex, normally the collision happen in the case of half duplex to remove or not remove, to reduce some extent about the collision. They have approaches they have used. That is the traditional method, carrier extension and burst, frame bursting. Okay. Now next is they have for full duplex we have already seen. Next is the physical layer. Under your physical layer, the topology, the arrangement of network they have used is the star topology, and there are normally the four implementations of the physical layer. Under your physical layer, that is the 1000 base SX, 1000 base LX, and 1000 base CS, and last one is the 1000 base T. They have divided these four. The physical implementation in two ways, that is the 2-wire and 4-wire implementation. The first three implementation, they have used the 2-wire implementation and the cable for the or CX because they have used the copper wire here. And the last one is the 1000/3, they have used the 4-wire for transmission and receiving purpose. And because of that, the implementation of the last one is the 4-wire implementation, and the first three is your 2-wire implementation. So this is all about your today's lecture. In the next lecture, we move to the next one. Till then, you mark your attendance in the chat box.